Now we will see the EMF equation, the EMF generated in a DC machine. So let me start with some basic assumptions. I'll assume that your DC motor is having P number of poles and the flux which is produced by each pole is pi. So total flux produced is equal to phi per pole into P, where P is the number of poles. Okay, and let the number of armature conductors be Z and number of parallel paths be A, because there are so many conductors wound on your armature and there might be so many parallel paths also. So if A is the number of parallel paths, now the effective number of conductors will be equal to Z by A. Z by A. So this is the total flux produced and this is the effective number of conductors. Now I'll assume that these conductors are cutting the flux with the speed of n. So then what will be the EMF developed or produced per generator? So EMF produced per conductor. What will be the EMF produced per conductor? It is equal to d phi by dt, right? d phi by dt per conductor. But what is the change in flux? What is the total flux which you are experiencing? The total flux is P into phi. And what is the time taken? Time taken for this total flux. So your time taken is equal to, this is your time taken for one rotation. If you take one complete rotation, what is the time taken? See, n is it is in RPM, rotations per minute. What I need is nothing but rotations per 1 second. So your speed will be n by, this is here, rotations per second. It is n by 60, right? So what is time taken for one rotation? It will be defaultly 60 by n, right? So now what is EMF which is developed now? So this is, what is the EMF developed? This is total fluxes P into phi, and what is the time taken for one rotation? It is 60 by n. This is for each conductor. This is for each conductor. Now totally how many conductors are there? Total EMF. This is P into phi. This is 60 by n. Into total how many conductors are there? Z by A. Right. Now if you rearrange this, n will go to the up. I'll get phi Z n P by 60A. This is the way, this is the total EMF which is generated inside your DC machine. Okay. See, the EMF induced is phi ZNP by 60. Right. So I am getting the total flux, the effective number of conductors, and the time taken for each rotation. Okay. So this is the total EMF which is developed in a DC machine, whether it is a generator or motor. Okay. So now let's do some problems on this one. There is a two-pole DC motor. There is a two-pole DC motor having wave wound armature windings. Two-pole DC motor means P is equal to 2, right? Wave wound armature. Wave wound means automatically it is number of parallel paths is defined by whether it is lap or wave. If it is lap, A is equal to P. If it is wave, A is equal to 2. So if it is wave, so A is equal to 2. Parallel paths is 2. and the machine has 500 conductors, which means Z is equal to 500. What will be the voltage generated, which means I want the EMF how much? When driven at 1500 rpm, N is equal to 1500 rpm. And assuming the flux per pole is 25 milliweber, which is nothing but 0.025 webers. So how to calculate EMF? All the things are available for you now. EMF is equal to 5ZNP by 60A, isn't it? So it is 0.025 into Z. Z is 500 into N is 1500 into P is 2 by 60 into A is, since it is wave winding, it is number of poles. Solve it, you will get the value of EMF which is generated. Okay, see, number of poles 2, conductors is 500, speed is 1500, wave wound, so A is 2, given flux per pole, and EMF generated, the formula is, just substituting the entire thing. What I am getting? 312.5 volts. Okay, 312.5. Okay, so now, next one. See, the 4-pole DC motor having lap wound armature winding. See what they are giving us? A 4-pole DC machine. P is equal to 4. Lap wound, which means A is equal to P. So A is equal to P, that is equal to 4. It is having 50 slots, each slot containing 25 conductors. So what is total number of conductors? 50 slots, each one containing 25 conductors. So how much it is? 1250. Determine the speed of the machine and the wounds. Flux per pole is 25 milliweber. Flux 0.025 Weber. And they have given generated EMF. E they have already given for you. How much? 300. We will utilize the same formula again. E is equal to 5ZNP by 60. E is already given 300 flux 0.025 Z 1250, and you need to find out P is 4, 60 into 4. You solve it, you will get the value of N here. Right. See. Number of poles is 4. Z is 1250. EMF is 300. Lap pound. So A is equal to P is equal to 4. Flux per pole. This is EMF generated. So solve it, you will be getting 576 rpm. This is the speed of your rotor. Okay. So I hope that now you are able to describe the construction, principle of operation of DC motor, the components. I'll ask you the figure, and you should name that figure, label it, and you should explain the parts which I asked. Okay. And I hope that you are able to list the applications of DC series motor and shunt motor. Shunt motor is used for constant speed applications. Series motor is used for high torque applications. Okay, and I hope that now you are able to compute the EMF also, which is developed in the DC machine. Okay, so these are your lecture level questions. The first question is a direct question. Explain the principle of operation of DC motor. Describe the different components within each sketch, and where are these motors employed. The second one, what do you understand by back EMF in a DC motor? Why it is called back EMF? This is a question which you should search on the internet and you should explain. Okay, and derive an expression for EMF generated in a DC motor. And the last one is a problem which we have done in this video lecture. Okay, try to solve them. Get back to the class and you will solve more number of problems, and more interesting topics are awaiting. Thank you.